Hi everyone. So I'm going to do one last thing today before I wrap up. I want to do an example. And so what I've done here is I've gotten the clean branch of the emulator. I've stripped out pretty much everything that is not just these 4 lines really. Getting events because I'm not going to really do anything graphical in this example. I just want to be able to catch the cue. So the quit button press, so I don't have to manually kill the emulator every time. Clearing the screen and updating the screen. I really don't even need this, to be honest. I'm just going to get rid of it. Really, all I care about is having a delay and getting my events so that I have my cue press. So now what I have here on the left and the right is I have 2 copies of the emulator. I have 2 different folders. So we have here, we have demo 1 and we have demo 2. I'll put this guy into build. So, yep. Nope. And so what I'm going to try and do is I'm going to use the asynchronous libraries to have 2 essential programs, because I'm going to compile these 2 folders. One of them to send a random number, and the other one will send me back the square root of this number. Now, it's just going to be really basic like demo, because the whole concept of the project can be very much the same. You send some sort of a value and you receive some sort of value. Now, I'm not going to be obviously doing a really in-depth example where I talk about where like you have to take into account handling other tasks at the same time. This is a very minimal demo, and filling it out to a more complex problem is up to you in the project. But so what we're going to do, firstly, we need to, in both tasks, we need to have a socket, because we're going to send on one socket and we're going to receive on another socket. So we're going to do this really basic. We're not usually put the sockets in like a header file or something, but we're going to do this really simply. We're going to define, to make this even easier on myself, I'm actually going to make you a bit bigger, and I'm going to, where are we at the moment? We are in 1. So I'm going to take 2, just go side by side so I can switch, copy and paste between them. So we're going to define tx. So we'll define this as, we'll define one as the master and one as the slave. So the one sending the number to get square rooted will be the master, and the one receiving will be the slave. So slave, I will use MOSI. So this is like used in SPI. So master out slave in port as 1, 2, 3, 4. Define MISO port as 4, 3, 2, 1. And now we'll just take these and we'll put these across here, because they both need to know which ones are which, right? And so we'll just put here number 2, this is the slave, and this is the master. Now, we're going to have to open sockets for both of them. So both of them are going to need 2 sockets. So we're going to have to do pretty much the same thing for both of them, but we're just going to make sure that they're sort of like, the other way around. Or to be honest, do we need to open sockets on both of them? Because we just put into one socket. No. We only need to open the receiving socket, because we're putting into the socket and we don't need to open the socket beforehand. I believe. I can't. We'll find out. It's been too long since I've written this code. But we're essentially going to open the receiving socket, because the receiving socket's the one we care about in this library, because the receiving socket's the one that's tied to the callback. And so this is where this asynchronous sort of interrupt style comes into it. So what we're going to firstly do, we'll create a function in both of them that is we won't fill it out yet, but we'll create the function for the callback. Now, if we look at the documentation for open UDP socket, we'll find that we have an AIO callback, and the AIO callback has to have this shape, meaning it has to take, it returns a void, meaning so it doesn't return anything. and it takes in 3 arguments: a size t rect buffer, a char pointer buffer, and a void pointer arguments. So we're going to make void, void, and this will be master receive. Let's make the master receive. It takes in a size t recursive size, a char pointer buffer, and it takes a void pointer args, right? Okay, cool. Now we'll just take take this, long day, and put it over here, and make this slave. Okay, cool. So now we have those functions defined. Now what else? Let's find our function. Our previous one, where was it? Open socket, UTCP, UDP socket. Now we need the endpoint, so we're not doing that, but let's just make some little defines. So just make things a bit clearer. Define IPv4 address. Now we're going to localhost, so we could pass in null, but we're going to pass in then 127.0.0.1. Now I believe this should, yes, char pointer, so it's a string notation of that. So I'll take you across here, and we'll put you here. So what else do we need? Callback, buffer size. So we're going to send a number, an integer, and we're going to receive back a float. So let's quickly let's find out how big a float is in bytes, because it depends on my system. Or actually, to be even smarter, we'll do it even like without. We'll say, so we want when we create it, we're going to create the buffer to the length of float, because we're going to receive a float, and the other guy's going to be receiving an integer, so we're going to have a size of int on his buffer. So what we'll do here, let's create them in main. Maybe we'll do it in our task. Okay, so here, we need a handle first, so we'll make a static AIO handle, and we'll call this is the slave UDP handle, null. Oops, up. And we'll also put him in here, and we'll call it the master. Okay, cool. So now we have demo task in our slave, and we're going to want to create the socket. So let's create it. What do we need? We need it returns a handle, so slave UDP handle equals AIO open UDP socket. First argument is the address, so this is our IPv4 address. The port is, so now this is the receiving on the slave. So the slave receives on master out slave in. So miso port. The buffer size, so he's receiving an integer, because he's going to take the square root of the integer he gets given, so size of integer, because if we look at, this is a bit hard on one screen, but if we look at manual of size of, oh, well, thanks for nothing. Essentially, size of returns the amount of bytes of a type. So it's going to return us the number of bytes, because this size here, number of bytes to be reserved as a buffer for the connection, right? So we have the size of int, and the callback. So the callback we have here, we've already created, which is slave receive. And args, we will, how can we make cool use of args? Let's store the previous answer as well. So what we'll do is we'll create a structure, and we'll call it slave args, and we're going to return, we're going to be getting back a float, so we'll store a float. Hold on, this is the slave, it's going to be taking an int, integer priv value. This is completely irrelevant why it's here, it's just to show, right? So we don't actually need this, but anyway. So now we will instantiate our args as well. So we'll create, actually instantiate it. So we'll make struct slave args my slave args equals, we'll just zero it out, statically allocate it and zero it out. And now we need a void pointer to it. So we could just pass in a pointer, but for complete good programming style, we'll actually typecast the rip pointer to the structure so that we don't get any compiler warning saying, hey, you passed in a struct slave args pointer instead of a void pointer. So here we have a void pointer of the address of my slave args. Oops. So there we go. So now we can see from the documentation, returns handle to the created connection or null, meaning null on error. So we can do here if slave UDP handle is equal to null, we know we have an error. So we're going to go in here, and I think there's a cool macro somewhere for like print error, slave connection, or slave UDP socket failed to open. And we'll just exit. I mean, we should do some cleanup, but otherwise this would take too long for this example. So we'll just exit with a failure code here. So to do the similar thing, we'll do pretty much the same thing here. Struct slave master args, and we're on master. And this guy wants to float value. Nope. Okay, so we're going to create our, instantiate our arg structure, struct master args, oops, my master, oh my god, master args equals, and we'll zero it out. Now, master UDP handle equals AIO open UDP socket IPv4 address. Now we want the MISO, because master in slave out, this guy, size of, and he's going to be receiving a float value, so size of float, and the callback for him is master receive, and he has a void pointer my slave args. Sweet. So you should, oh, my master args. Whoops. Okay, so now where we're up to, we need some more error handling, so we'll just quickly take him and put him over here, and then quickly change from lines 54 to 56, change slave to master. Easy. Okay, so now got our sockets created. So we should be able to run that. But now what we're going to have to do, we're going to have to take, the master will take control. So the master is going to send an integer, and then he's going to receive something, right? So pretty much here in the slave, he's not going to do anything, and the master is going to every second send, right? So the sending is going to happen on the master inside of the main while loop, whereas the returning the value is going to happen within the callback of the slave, because it's going to get triggered, like interrupted in the callback of his receiving function callback, and then he'll send the value he's calculated, right? So if we go into the master, let's have a look. AIO socket put. So the protocol Then we need either UDP or TCP, the address, the port, the buffer, and so the buffer size. So firstly, what we need is that we obviously need a value. So we're going to have in here, we'll just create a static int, random value. So we'll just create u. Now we need to include rand. I think rand is in the standard lib. Don't use it that often. So here, what first thing we're going to do is we need to create a random value. So random value equals rand. Is it there? I think. Let's have a look. Man rand. So can we full screen? No, this is not what we want. Anyway, I'm pretty sure. Anyway, rand, and then we want between like a certain number, so let's just say maximum like 100. And plus 1, so that we go between 1 and 100 and not 0 and 99. So then we have our value that we want to send. Now the port we know, the address we know, the buffer we have, because our buffer in this case is random value, and this buffer size. So what we'll do is we can then send. So we can say, we'll do some error checking, int return 0 on success. So we'll do this inside of an if statement. So if not, or if there's a value return, we have an error. So we're going to go if AIO socket put protocol. Now, I believe, why is this split like this? I need to fix up this documentation. See also, okay. So it must just be UDP. UDP, now what's next? S address. This would be IPv4 address, the port. So we're on the master, we want to send to the slave. So the slave in port. So this is master out slave in port. And we want to send the buffer, which is random value, and we need to point it to it. So random value. And the size of the buffer. So size of random value, because it's an integer, this will just pretty much probably like a 64 bit, so it's going to spit out like 8 or something. There we go. We can just format this quickly to make it a little tidier. And why? All right, because yeah. So this is an if statement. So if this has happened, this means that we have gotten -1. So we have got an error. So let's just print an error. And we'll just say like failed to send from master. Or something like this, right? Simple. Cool. So now we'll go to our slave. And I'm not gonna do the whole problem of building at the end and get all the warnings and errors at the end, because it's a great idea all the time. So the slave, we don't need anything in the loop here, because everything on the slave is going to happen in the callback. So to be now the slave is going to receive the integer, so it's going to need int. Well, let's go and have a look at the callback. We're going to need some sort of an int. So int receive value. Now, so if we want to know how to write these, a really easy way of looking at how you read the data in from these structures would be to look at the demo code. So we look at GitHub. I'll make this a bit bigger. Sorry for the slow loading times. When I'm recording my screen, my computer just cannot handle much. The beauty of using a ancient ThinkPad. FreeRTOS emulator. And we'll look at the master branch, which has a lot of async IO demo codes in it. So look at some of these callbacks. Now, I made a couple of them, which I sort of talked about in the last video, where it prints out the string that's received. So draw FPS, nope. Handle one here. So it's just referencing buffer. In this case, it's a char string, like a char pointer, and then read size is going to tell us how many. Like it's not using any of them here. So I mean, this one doesn't actually show us too much, but there is a handy function. I have to remember what it's called. A to I think. So A to I, convert a string to an integer. So we could use this, like we could convert the integer to a string, put it in a string and send it, but that's obviously not what we're going to want to do. So I don't know why I'm doing this. But essentially we have a char pointer because it's a char pointer buffer, meaning that I use a char pointer in this case because it's just bytes. But the integer is going to be starting at this address for the length of an integer. Meaning that in memory, since memory is sequential, at this location is also the integer. So if we typecast this char pointer to an int pointer, we can get our value. So we're just going to go int pointer buffer, but now we want to get the value at that address. So we've typecasted it here, just brackets to make it really clear. So we've typecast buffer to be an integer pointer, and then we're dereferencing it to take the value, right? So let's print this. Print f received, this is the value. I will firstly calculate actually the square root. So the float square root value equals, now we will need manual square root, I believe. So what does it return? It returns a float square root f. So I don't want the double, I want square root f. I need to link with the math. We'll see, I think that might already be included in the make files, but we can add that easily later on. So we're going to want square root f. Here we see float. And we're going to take float of receive value. So now we have this the square rooted value, and so we're going to want to receive the square root is, and then I believe it's just percentage f to print a float. New line ended, and then here comes receive value, and then a square root value. Easy. Okay, cool. So now we've gotten the integer and we've gotten the float value of it. Now we want to send it back. So we're going to go AIO socket put UDP, back to our documentation, the address, IPv4 address, port. Now we're going from, what are we on the slave out, master in. Slave out, master in, miso port, buffer, reference to data to be sent. Now we want to send the square root value. Size of length of data, size of square root value. Now we can also, where are I? We should also error check this, just because it's what's the good thing to do. Now, have I forgotten anything? Port, nope. Print error, failed to send the square root to master. So now we've got that done, and it's a void, so we don't need to return. So now we've got a callback. But now one thing that we didn't look at was that we have this args thing that I've got here, which we've passed into our to our connection as this structure here, which has been statically allocated in the initialization code of our vDemo task. So what we're going to do is we want to store the old value. And so we're always just going to store essentially, like we'll calculate the value and store it in this structure. Why not, right? And so it'll always, until we calculate a new one, it'll be storing the old one. So initially it's not storing anything, but so maybe, or at the moment it's storing a 0 because we zeroed it out. But how we're going to access this argument is we need to typecast it. So in this function, it doesn't know the type, it's a void pointer, and this allows you, as I mentioned in the last video, to be really creative into what this callback actually has as arguments. Because if you want 10 arguments, you just put 10 variables in a structure and boom, there is 10 arguments. You just need to typecast the structure first and then you can get the 10 arguments out. But so we'll do it the easy way, which is really, like, I find kind of clean, which is we create like a pointer to the typecasted void pointer. And so we can then just normally, it's just really clean because of code completion. So we're going to need a struct slave args pointer. And we'll call this my slave args. So this is actually the same name here, but because of scope, we're in two different functions, it doesn't matter. Equals, now we're going to typecast this struct slave args pointer args. And so now when we reference my slave args, it knows that it is a struct slave args. So it contains the integer value, previous value. So my slave args is pointer, so we use a little arrow, previous value equals square root value. Great. And so even when this returns, because this structure has been statically initialized here in this task, and we're using a pointer, this variable is still going to exist in memory even though this returns, because this value here is local to this callback scope. So once this function gets returned, like once this function returns, this value in memory doesn't really exist anymore, but this one will continue to exist. So let's just check that it works. We'll say like, before we set it, we'll do another print statement here. And we'll just say previous square root was %f. New square root is %f. Okay, there we go. So then we can just show that we've like sort of updated it. We should see over time that it's updating the previous value or storing the previous values. So now I should put this after here. So in here we want to show my slave args previous value, and then in here square root value. Okay, great. So that's one more thing done. So that means that the slaves callback is pretty much done. Now where the next step in the whole send process, on the master we've set up to send, then the slave receives it, calculates the square root, sends it back, and now we want to go into the master, into its callback, and here we'll save the value and we'll just display it, right? So we firstly want to get the value out. So float receive value, and this will take a is equal to, and similar in the last one, we'll just it's a float pointer at the location of buffer, right? And we're taking the value of that location. Now we also want to, like, while we're at it, we'll typecast our arguments. So we'll say struct master args pointer my master. Oops, I won't get my master args equals typecast is struct master args pointer args. Say args one more time. Cool. So now we have our float, and we'll store this in our let's print out the previous one and then we'll store it. So we'll do the same as we did in the slave one. So we'll print f previous value. So when we run this for the first time, it'll show 0 because we zeroed out our arguments. So at the beginning it's storing 0. Previous value was percentage f. New value is percentage f. Cool. Now we'll save it. So master args. Oh, but here in this one we'll save the. Well, I've done this wrong. Previous value. So this is the one that we don't want to sort of square it. Previous value that we were sent. Previous sent value was, and this is not a float. This is an integer. And this is not is previous value, and this should be received value. Ha! Knew there was something wrong. Okay. Cool. No, not cool. Receive value. Receive size. Nope. Again, wrong. Value. Now we're good. Back to this one. Master args. Now we're dealing with the floats. So previous value is equals received value. But we've forgotten to finish this. Master args. Previous value. No, my master args. And now we want the receive value. Cool, and now we're just forgetting my here as well. Great. So I think that should be it done. Now let's have a look. If we get errors, passing that put from incompatible pointer type, float pointer square root. So this is warnings. Like I treat warnings in my code like errors, and I don't like them. So in this case, for number, this is for 2. So this, so I'm dealing with floats. We have, well, this is 1. So here, on line 28, that makes no sense. I read this wrong. I know, here, on line 54. Square root value. Oh, it even complained to me, I think, before. But yeah. So the problem is that the call to AES socket put takes a char pointer to buffer. But here we have square root value, which is a float. So we need to just typecast it. So we'll say this is a char buffer, just to get rid of the warning, right? And so if I make this again, we should hopefully get rid of that error. Yes. Macro expansion, this one I think is on me. In expansion error, macro expansion. Some parts of the macro expansion are not guaranteed by this if clause. Oh, so this is also on me. Okay, so we won't worry about that one. So let's make this one. Probably gonna have the same error on the put of the typecast, the same warning. Yes. So we'll fix up that one, which is over here. Right here, random value on 77, I believe. Yes, 77, this guy here, random value. So we just typecast you to a char pointer, clear up our, okay, now the moment of truth. So they will show errors until, for instance, let's start up the master first, and he'll open the socket and we'll try to send, but it's not going to work because the receiving socket hasn't been opened by the slave yet. So the master for us is slave. The master is number 1. So let's see what we get. Open socket on port. So this is giving us some errors. Now let's try this guy. Here we go, look. And we can see we've got, like, for instance, if we stop these, oh wait, if we go Q and Q, this is kind of hard to see, but for instance, the new square root is 60 and the previous one was stored in here. The previous value was, or the previous value is 7 point whatever, and we have, so it seems to be working. I mean, you can see that the randomness is not really that random, given that we haven't seeded the random generator, number generator for this. But I'm happy with this. I mean, this seems to work. So, I mean, I think that's a good enough example. I'm glad that it just worked first try. So if you have any questions to using this stuff, I might actually just save this onto a new branch, and I'll push this to the emulator. So we'll just go have a look at what we should change this stash. We'll check out branch UDP example. And get stash pop, and then we'll just make example code from a YouTube video. Great. So now you should be able to find this code online and go through it at your own perusal. Thanks for watching, and I hope this helps. If you have any questions, ask Philip or I. We're happy to help.